So, we already seen what is Coulomb's law. What does Coulomb's law tells you? Coulomb's law gives you the force of attraction or repulsion between any two charges kept in a medium. Now, according to Coulomb's law, this force of attraction or repulsion F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now, we will see this Coulomb's law in its vector form. There are two charges Q1 and Q2. They are separated by a distance of R. Q1, Q2 are the two charges separated by distance of R. Let F21 vector be the force exerted on the charge Q2 by Q1. What is F21 vector? It is a force exerted by the charge Q2 on by Q2, say correct, by Q2 on Q1. So, it is given by 1 by 4 pi epsilon naught Q1 Q2 by, so F21 vector is the force exerted on the charge Q2 by Q1. What is F21? F21 enters in a force exerted by the charge Q2 on the charge Q2 by Q1. That Q2 mele Q1 on the ivlo amount of force exert pannadhu. So, according to Coulomb's law, we are going to write the equation. So, R12 square into R12 cap, where R12 cap is the unit vector. It acts from the direction Q1 to Q2. This force will be acting from Q1 to Q2. This is the force exerted on the charge Q2 by Q1. Similarly, let F12 vector be the force exerted on the charge Q1 by Q2. Similarly, I can also write this equation, isn't it? So, F12 is equal to say 1 by 4 pi epsilon naught Q1 Q2 by R21 square into R21 cap, where this R21 cap is nothing but the unit vector. It gives you the direction. The force is acting from Q2 to Q1. So, let this be equation 1 and this be equation 2. Now, if you see these two unit vectors R12 cap and R21 cap will be equal in magnitude and they act in opposite direction. These two will be having equal magnitude, that is these two forces will have the same magnitude but they act in opposite direction. So, how I can write this equation? I can also rewrite this equation as this equation 2 as F equal to F12 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 by R21 square into minus R12 minus R21 cap. I can also write this equation since we know that R12 cap is equal to minus of R21 cap. So, in this way also I can write this equation. Equation 2 is rewritten as R12 and R12. So, minus goes out. I can also rewrite this as equation. Now, this one is nothing but your equation 1. So, I can write this as F12 vector is equal to minus of F21 vector. So, the force exerted on the two charges Q1 and Q2 will be equal in magnitude and they act in opposite direction. So, how will be the force exerted on these two charges which are separated by a distance R? They will be equal in magnitude and they act in opposite direction. So, this is the way how I can write the Coulomb's law in its vector form. Coulomb's law eppadi vector form la eludradhu, this is the way how I can write it. Just I want to represent the direction in which the force is acting. When you write the Coulomb's law in its vector form, you are going to add this term, that is the unit vector. It gives you the direction of the force in which it acts. For example, in this equation 1, this unit vector R12 cap gives you the direction of the force. It acts from Q1 to Q2. Clear? So this is the way how I can write the Coulomb's law in its vector form. Now, in the system, I have only two charges. In the system, we have only two charges present. For example, there are so many charges present in a system. How to find out the net force exerted by the charges on a charge Q? Take a system. There are so many charges. Let it be n number of charges. Let Q1 be a charge, and Q2, Q3, Q4, like this. There are n number of charges in a system. So I want to find out the net force exerted on this charge Q1 due to the other charges present in the system. So how to find out the net force on this charge Q1 due to the other charges present in the system? I can find out the net force by taking the vector sum of all the forces exerted by the other charges separately. So how to find out the net force? It is exerted by the on this charge Q1. It is given by the vector sum of the all the forces exerted by other charges separately. Let F12 vector be the force exerted on the charge Q1 by Q2. Let F13 vector be the force exerted on the charge Q1 by Q3. Similarly, F14 vector be the force exerted on the charge Q1 by Q4 up to n number of charges. So how to find out the net force? It is given by the vector sum of, let F be the net force acting, which will be equal to the force exerted by all the other charges. You just take the vector sum of all the forces exerted by the other charges separately. So it is given by F12 vector plus F13 vector plus F14 vector up to n force. So thus we call it as the principle of superposition. So from this principle of superposition, what I can calculate is principle of superposition. What is the use of principle of superposition? This principle of superposition, it is used to find out the net force acting on a charge due to the other charges present in the system. Eppadi calculate pandrathu net force? It is nothing but just take the vector sum of all the forces individually. That gives you the net force. So eppadi kandupidikalam net force acting on a charge? If there are so many charges present in a system, just the vector sum of all the charges. This we call it as the principle of superposition. This is principle of superposition. This use in it is used to find out the vector sum of all the forces individually due to the other charges present in a system. Then, so far we have seen the force of attraction between any two charges. Coulomb's law. If there is a point charge or charge and the charge is because of this static charge Q or charge Q. In the charge it will be acted upon by forces. That is why it is gaining the potential energy. Up to how much area this force is felt by any charge. So I have a charge Q. I want to find out up to how much place its force is experienced. It will experience how much distance it can experience a force. How I can calculate if I have only one charge present here, you have only one charge Q. Is it possible for me to find out up to what extent its force will be felt? It is not possible if I have only one charge. I can't able to find out how much extent its force will be felt. But if I brought another charge, let that charge be Q naught. I am bringing another charge. Let this charge be a test charge Q naught. I am bringing this charge closer to it. So if I bring another charge, then only I can find out this charge, how much area it is going to felt its force. எவ்வளோ ஏரியாக்கு இதை சுற்றி இந்த சார்ஜை சுற்றி இதனுடைய ஸ்பேஸில் எவ்வளோ ஏரியாவுக்கு இதனுடைய ஃபோர்ஸ் இருக்கும். அதை எப்படி கண்டுபிடிக்க முடியும்? பை பிரிங்கிங் another charge towards it. இன்னொரு சார்ஜ் அது கிட்ட கொண்டு வந்தாதான் I can easily find out how much is the area its force is felt. That space around a charge up to which its force is felt, that we call it as the electric field. So how I can define electric field? It is nothing but the space around a test charge. So what is the electric field? Electric field is nothing but the space around a charge up to which its force will be experienced. So if I have only one charge, I can't able to find out how much distance its force will be felt. If I bring another test charge only, I can easily find out up to how much distance or how much space its force will be felt. Thus we call it as the electric field. How to measure this electric field due to a point charge? எப்படி மெஷர் பண்றது இந்த எலக்ட்ரிக் ஃபீல்டா எப்படி மெஷர் பண்ணலாம்? I can easily measure this electric field by electric field intensity, which is nothing but electric field intensity is equal to force experienced by a unit positive charge. How to calculate this electric field at a point due to a point charge? It is given by force experienced by a unit positive charge. So electric field intensity is used to calculate electric field. I can write this in the way of a formula. It is nothing but force experienced by a unit positive charge. That we call it as electric field intensity. This electric field intensity is a vector quantity. And can you say the unit for this? What E equal to? E is the symbol for electric field intensity. It is equal to F by Q. What is the unit for force? Force unit is Newton. What is the unit for charge? Coulomb. So what is the unit for electric field intensity? E equal to Newton per Coulomb. So I can also say this as simply electric field or electric field strength or electric field intensity. It is used to find out the electric field at a point due to a point charge. So this is a vector quantity. E equal to F by Q is a vector quantity. If I write this in vector form, E vector equal to F vector by Q, where Q is the charge present there. Its unit is Newton per Coulomb. Now, in an electric field, so this is the electric field due to this point charge Q. If I take any point in this electric field, at different points, if the charge experiences the same force, we will see first what is meant by uniform electric field and non-uniform electric field. In this electric field, if this charge Q experience same electric force at different points, that electric field we call it as uniform electric field. So what is uniform electric field? In an electric field, if a charge experience same electric force, எந்த பாயிண்ட் எடுத்தாலும் இந்த எலக்ட்ரிக் ஃபீல்ட்ல இந்த சார்ஜுக்கு வந்து அது எங்க இருந்தாலும் இந்த பாயிண்ட்ல இருக்கலாம், இங்க இருக்கலாம், இங்க இருந்தாலும் if this charge Q experience the same electric force, எங்க இருந்தாலும் அதுக்கு ஒரே மாதிரி electric force experience ஆச்சுன்னா that electric field we call it as uniform electric field. In a uniform electric field, the electric field intensity will have the same magnitude and direction. So how will be the electric field intensity? In a uniform electric field, it will have the same magnitude and direction. Example for this uniform electric field is the parallel plate condenser. Parallel plate condenser is a very good example for uniform electric field. Then, if this charge Q experiences different electric forces at different points. Now, if the same charge Q, if it gets different electric force, if it experiences different electric forces at different points, that electric field we call it as non-uniform electric field. In a non-uniform electric field, this electric field intensity will be different in different directions. Very good example for non-uniform electric field is electric field due to a point charge. So what is the good example for non-uniform electric field? It is nothing but electric field due to a point charge. Now we will see how will be this electric field intensity due to a point charge? Before going further, we know that E equal to F by Q. From this, I can also calculate how much force a charge can experience. From this formula, F equal to E times Q. So, this formula I can calculate how much force a charge can experience. It is given by F equal to EQ. For this, we can have a very good example. For example, I take electron. In a uniform electric field, I am having an electron. So, let this electric field intensity, where this electron is kept, let its value be 100 Newton per Coulomb. So, this electron, we know that what is the unit, what is the magnitude for this electron? It is given by E equal to 1.6 into 10 power minus 19 Coulomb. So, this electron is kept in a electric field of intensity 100 Newton per Coulomb. Can you find out how much is the force experienced by this electron? It is given by the formula F equal to E times Q. So, what is the force gained by this electron which is kept in a uniform electric field? E value is 100 into 1.6, 10 power minus 19. So, what is its value? Multiply this 1.6 into 100. You will be getting 160 into 10 power minus 19. Force unit is Newton. How you got this Newton here? For E, we got Newton per Coulomb. For charge, I will be getting Coulomb. Coulomb gets cancelled. So, finally, we will be having only Newton. So, this is the way you can find out the unit for any physical quantity. Next one, we will go for the electric field due to a point charge. Electric field due to a point charge. There is a point charge Q. Here I have another charge Q naught. Let P be a point at this where the test charge is kept. Now, we know that. Now, I want to find out due to this point charge Q, how will be this electric field if a point charge is placed at a point. We know that by formula E equal to F by Q naught, because force experienced by a unit positive charge. I can also write this. By Coulomb's law, we know that what is the force of attraction or repulsion between these two charges. It is given by 1 by 4 pi epsilon naught Q1 Q2. Here Q1 Q2 are your Q and Q naught. Q naught by R square. Let R be the distance between the two charges, and here I have Q naught. So, these two gets cancelled. So, finally, I will be getting E equal to 1 by 4 pi epsilon naught Q by R square. So, this will be the electric field intensity due to a point charge. In this way, I can write the electric field intensity due to a point charge. So, do not forget this formula E equal to Q by 4 pi epsilon naught R square. If I want to find out the force of attraction or repulsion between the two charges, it is given by 1 by 4 pi epsilon naught Q1 Q2, that is a product of two charges, by R square. So, these two formulas are very important. You may get in problems. Now, we are saying about electric field and how will be the electric field due to a point charge. So, for we are saying what is meant by electric field, how will be this electric field due to a point charge. Just a review. Now, in this electric field, how will be this electric field lines? That is, electric lines of force will be. This was first studied by Michael Faraday. Michael Faraday, he studied about this electric field lines. He used this as a aid for visualizing the electric and magnetic lines of force. Just he has studied about this electric lines of force, how they will move. It's an imaginary straight or curved line path between any two charges. He studied about this. For example, if I have one charge positive plus Q and another charge minus Q. Here I have two charges, one is plus Q and the other is minus Q. These two charges are of same magnitude. It is 1 coulomb and 1 coulomb, but they are opposite in polarity. This is positive, that is negative. Now, those magnetic electric lines of force will always start from positive charge and ends in the negative charge. How will be the direction of this positive lines, electric lines of force? It starts from the positive charge and ends in the negative charge. Eppadi move agum in the electric lines of force? Electric lines of force eppadi electric field பத்தி படிச்சிட்டோம். In the electric field it consists of only electric lines of force. The electric lines of force eppadi இருக்கும்? How it will be? We can't able to see, அதை பார்க்க முடியாது, but I can able to experience it. So these electric lines of force are imaginary, straight or curved path along which a unit positive charge tends to move. ஒரே ஒரு யூனிட் பாசிட்டிவ் சார்ஜ் எப்படி மூவ் ஆகுது அதை இமேஜினரியா டிரா பண்ணா this will be the shape of the electric lines of force. That was done by Michael Faraday. அவர் என்ன சொன்னாரு? How will be the moment of a unit positive charge? எந்த பாத்ல அது மூவ் ஆகும்? It is a straight path or a curved path. This we call it as the electric lines of force. So always this electric lines of force start from positive charge and ends in the negative charge. When they move like that, so here it will be very slow because this positive will attract a negative charge. Beginning la konjam slow ah irukum and the force of attraction, but when it approaches near the negative charge, its force increases and it will be thick. Like this it will go. Now they will never intersect with each other. These electric lines of force will never intersect with each other. Like this they will be. Which one? Electric lines of force. If I draw a tangent, so these are the electric lines of force between any two charges plus Q and minus Q. So they will start from positive charge and they will end in the negative charge. They will never intersect with each other. That means the electric lines of force never intersect. If I draw a tangent to any line, this direction gives you the direction of the electric field. So if I draw a tangent, that gives you the direction of the electric field. Now, if those electric lines of force are closer to each other, what that mean? Electric lines of force are nothing but electric field intensity. If those electric lines of force are closer, ellame kitta kitta irundaduna, I can say at that place this electric field will be large. Electric field intensity will be large if the lines of force are closer. The electric lines of force எல்லாம் எல்லாமே கிட்ட கிட்ட இருந்ததுன்னா அந்த இடத்துல electric field large ஆ இருக்கும். Same way, if the electric lines of force are far away from each other, at that point this electric field will be less, will be small. So it may be large or small, it depends upon the electric lines of force. Electric lines of force closer ஆ இருந்ததுன்னா electric field is large. Electric lines of force, if they are far away from each other, தூரமா இருந்ததுன்னா ஒண்ணுக்கு ஒண்ணு, then electric field is small at that point. Now, if I have only one positive charge, positive charge start பண்ணிட்டு தான் negative charge போய் முடியும். எது? electric lines of force. ஒரே ஒரு point charge இருந்ததுன்னா this electric lines of force will be pointed away. This way they will be pointed. If I have one negative charge, how will be the electric lines of force? If it is a positive charge, they will be pointing away. If it is a negative charge, they will be pointing towards it. So always remember this. If it is a negative charge, it will be approaching the negative charge. If it is a positive charge, it will be going away. So in this way, the electric lines of force move. Now, we will find out for how many lines of force a unit positive charge will emit. A unit positive charge, let n be the number of lines originated from unit positive charge. ஒரே ஒரு யூனிட் பாசிட்டிவ் சார்ஜ் இருக்கு. இந்த யூனிட் பாசிட்டிவ் சார்ஜ் எத்தனை நம்பர் ஆஃப் லைன்ஸ் ஆஃப் ஃபோர்ஸ் it will have. Thus I can easily find out by a formula, let n be the number of lines of force originated by a unit positive charge. It is given by n equal to q by epsilon naught. That is, it will give 1 by epsilon naught times the net charge q. So in this way, I can easily find out the number of lines of force originating from a unit positive charge. N equal to q by epsilon naught. So these are the properties of this electric lines of force. These are the properties of electric lines of force. Properties of electric lines of force, from what we have seen 5 points. First one, electric lines of force always start from positive and ends in the negative charge. Second point, they will never intersect with each other. Third one, if I draw a tangent to any line, the direction gives you the direction of the electric field. Fourth point, if the lines of force are closer to each other, electric field is large. If the lines of force are far away from each other, electric field is small. Then, how to find out the number of lines of force originating from a unit positive charge? It is given by n equal to q by epsilon naught. So these are the 5 points which states the properties of electric lines of force. The 5-mark question, be thorough in all these points. Now, so far we are seeing about the charges and the forces acting on the charges. Now, if there are 2 charges present in a system, let thus be plus q and minus q, and they are separated by a distance 2d. Here I have 2 unlike charges of equal magnitude. 2 equal and opposite charges. 2 equal and opposite charges, they are separated by a very small distance. This 2d is nothing but the distance of separation between the 2 charges. These 2 charges are unlike but equal and opposite charges. If they are separated by a small distance 2d, since it has both, what is the force acted on this charge plus q? It is given F equal to plus QE. F equal to plus QE. Same way, here this charge will experience a force F equal to minus QE. So the magnitude of these 2 charges will be equal, but they act in opposite direction. Clear? So since they have equal amount of force exerted on these 2 charges, they will constitute a dipole. Thus we call it as a electric dipole. So how I can define an electric dipole? Electric dipole, when 2 equal charges, equal and opposite charges, if they are separated by a small distance 2d, they constitute a electric dipole. Thus we call it as the electric dipole. How to measure this electric dipole? It is given by electric dipole moment. So what is electric dipole moment? Electric dipole moment is used to measure this electric dipole. The symbol for this electric dipole moment is small letter p. It is given by product of one of the charges. Since both the charges have the same magnitude, it is given by which one? Electric dipole moment. Small letter p is equal to product of one of the charges into the distance between them. Here 2d is nothing but the distance of separation between the 2 charges. So p is equal to q into 2d. This is the formula for finding the electric dipole. Can you write the unit for this? What is the unit for charge? Charge kinna unit? Coulomb. Good. Unit for distance is meter. So here electric dipole moment unit is coulomb meter. It is a vector quantity. It is a vector quantity. And if you see the direction of this electric dipole moment, it always acts from minus q to plus q. So, what is electric dipole moment? Electric dipole moment is given by P equal to q into 2d. It's a vector quantity. Its unit is coulomb meter, and it acts from minus q to plus q. Now, we will see some examples for electric dipoles. So, what is my electric dipole? There should be two equal and opposite charges. They should be separated. They should not coincide with each other. Very good examples for electric dipoles are water molecules, ammonia, carbon dioxide, and chloroform. So, these are very good examples for electric dipoles. Chloroform, carbon dioxide, ammonia, water molecules. In all those examples, the positive and negative charges. Shall I take a break?